Hey guys, welcome back. In this video, I want to solve this very interesting question. It says that if y equals to x raised to x raised to x raised to x, then find dy by dx, which means we are simply told to differentiate this function. But if you observe very carefully, we have y equals to x raised to n, where n is the integer, okay? Then what we do is we apply the power rule of differentiation as y prime equals to n x n minus 1. But here y equals to x raised to x raised to x raised to x. What we observe is that we have the variable x, but this variable x is raised to the power which itself is of the variable, same variable, right? So we simply cannot use the power rule of differentiation, so we have to do another approach. Okay, so what we will do is that I will assume that let this part x raised to x raised to x be something like t. Okay, so we get y equals to x raised to t. Okay, and this t itself is, as I've already said, this is variable, so we cannot isolate or use this power of differentiation to differentiate this. Okay, so what we will do is we will use implicit differentiation, and we will also use logarithmic concept to differentiate this function. So if we have logarithm on both sides, we will get ln y, right, equals to t times ln of x. Now we can differentiate this implicitly. Okay, by differentiating this we will get y times dy upon dx equals to this one. We have to use product rule, so it will be t times 1 over x plus ln x times dt over dx. Okay, so here dt over dx and dy over dx I will denote as y prime and t prime. Okay, so we will get y prime over y equals to t times 1 over x plus ln x, right, times t prime, which will imply that y prime equals to t times 1 over x plus ln x times t prime whole multiplied by y. Okay, so this is very important relation that we will use later. And here, if you observe very carefully, we know the value of this t, we know the value of x, we know the value of ln x and y, but we don't know the value of this t prime. So we have to do another step to find the value of t prime. So how we will do is we will consider this function again here, this one. Now we have t equals to x raised to x raised to x. Okay, again I will put this as k equals to x raised to x. Okay, then our t will become x raised to k. Okay, so we will apply the same step as ln t equals to k times ln of x, right? And by differentiating implicitly we'll get t prime upon t equals to k times 1 upon x plus ln x times k prime, right? So our t prime will be k times 1 over x plus ln x k prime whole times t. And here also we don't know the value of this k prime, so we have to find it by taking another step. We have that k equals to x raised to x. Okay, and ln k equals to x raised to ln x, right? So we have to again differentiate implicitly, and we'll get k prime upon k equals to x times 1 over x plus ln x times 1, right? And which will be k prime equals to x1 plus ln x whole multiplied by k. Okay, so we know the value here, all the value of k here. So now we have to compute the value of this k prime, t prime to get the value of this y prime, because this y prime contains the term of this t prime and this t prime contains the term of this k prime. So we have to do lots of plugins. Okay, so we will have to compute this now. Computing, okay, computing k prime. We'll compute this k prime. K prime equals to what? This k is x raised to x, right? It is x raised to x times 1 plus ln x. Okay, and we can distribute this x raised to x as x raised to x plus x raised to x times ln x, because we have to do lots of simplification later. Okay, now we know that t prime equals to t times k times 1 over x plus ln x times k prime, right? So which can be simplified as t prime equals to, this t value is x raised to x times, what is the value of k? K is x raised to x times 1 over x plus ln x, and here this k prime is this one, right? So I have to insert this. We get x raised to x plus x raised to x ln x, and the value is t prime equals to x raised to x raised to x raised to x times 1 upon x plus this ln x we have to distribute here, x raised to x ln x plus x raised to x ln x whole squared. So this is t prime. Now we have y prime equals to y times t times 1 upon x plus ln x times t prime, right? So we will get the value of y is x raised to x raised to x raised to x whole times, here the value of t is x raised to x raised to x, right, times 1 upon x plus, and the value of t ln x, right, and this whole is the value of t prime, right? So we'll have, and we will get now y prime equals to, see here, this y is multiplied to all, so we can factor this out. We'll get x raised to x raised to x raised to x, and we also observe that this x raised to x raised to x and this x raised to x raised to x is multiplying to all the terms, so we can factor this out, times x raised to x raised to x. Now what is left inside? We are left with 1 over x plus, here this term is factored out and this term we have to distribute to all the terms, right? So we will get, so this is the simplified version. Now I just want to factor this out, this one and this one, but I can't do right now because this term doesn't have the x raised to x term, but I can manipulate this little bit so that I can get x raised to x out. So if I want to factor this out, then I will have something like x raised to x times some number should be 1 over x, right? So this one which written as x raised to minus 1. So I have to find this k, so I will find the k by just dividing this term, x raised to negative 1 divided by x raised to x, right? So which can be written as x raised to negative 1 times x raised to negative x. So k value is x raised to negative 1 plus x. Okay, so if I put this inside this value, I can factor x raised to x out, right? Because if you multiply this, then it will give x raised to minus 1. So by doing this, what we will get is, finally we will get y prime is equal to x raised to x raised to x raised to x times x raised to x raised to x times x raised to x. Now this inside, what is left? X raised to negative 1 plus x, right? Plus ln x upon x plus ln x whole squared plus ln x whole cubed. Okay, and finally we can express this as fraction as y prime equals to. So this is the final answer for the derivative of x raised to x raised to x with respect to x. I hope you have enjoyed this video, and if you have seen this confusing while isolating the term and simplifying the terms, You can try it yourself so that you will get a clear picture of what's going on. I hope you all have enjoyed this video, and I'll see you in the next video. Thank you.